Okay, using a program called Geometer Sketchpad, I'm going to show you guys what the first example on section 7.3a looks like. That's the problem where you have the volume of the solid whose cross sections are squares, one side on the xy plane perpendicular to the x-axis, bounded by the circle x squared plus y squared equals to 4. So notice over here on the right hand side I have y equals to plus or minus square root of r squared minus x squared. And I have listed r to equal to 2, and I can actually change that to be anything that I want. So here's the circle base right here in the middle, and I'm going to click on these things over here on the left hand side. So if you notice show chords, so we'll see where the chords are. I'm going to drop the y-axis flat so you can kind of see it in 3D. And these are what 4 squares would look like, sitting on top of 4 different length chords on our circle. I'm going to rotate this a little bit so you can see where those four squares are, and then I can also sweep it so you can see how the square size changes as it goes through the circle from left to right. Can you guys describe what the solid would look like? It's kind of hard to see here. Okay, I'm going to stop the sweeping. I'm going to show you the 4 squares, and I'm going to show you the solid. So notice the squares are being formed, and it's actually summing up the square area. What are these 2 black curves that you see over here along the edges? Those are the top 2 vertices of your square. Notice how they're coming together. It's forming a solid. So here's our solid, and here are the 4 squares inside of it. And you can actually see the solid with the square sliding through it. So this is what it looks like, and I have a model for this to show you guys. I'll probably show you guys in class later on. Now our second example had the same thing as example 1, but the cross sections were equilateral triangles, so I'm going to show you the same kind of thing. Here we have our equation. R is equal to 2, so it has a circle of radius 4, and if you notice I can actually change this. I can make this radius change, but I want it R to be 2. So here are the chords. Let's drop it flat. Here are the 4 equilateral triangles. Notice the length of your base of the equilateral triangle sits on the edge of that circle. So can you guys describe this solid? How does it look the same, or how does it differ from the one we just saw with the squares? Okay, well here's the solid. Now notice the black curve right here through the middle. That's created by the vertex of your triangle. And here we go again. So I don't know if that's what you imagined in terms of the solid being created, but this is what it looks like. And again, hard to draw on paper by hand, so that's why I try to show you guys how to draw it the way that I did in your notes on the other video. We could also do this with isosceles triangles, and I don't think I did this one with you guys on your notes, but I'll just show it to you really quick. You can see 4 isosceles right triangles with one leg on the base. And here's the solid. Notice it's kind of tilted over to one side. That's because the triangle has its vertex over on one side of it. But notice it's not flat, it's still rounded because it's on a circle base. And this one is example 3 on our notes, where we have the triangle base with the line y equals to 3 over 4x minus 3 as our base, and we're going to fit semicircles right over the top of it. So this time, if you notice, if you remember from the example, they are going to be perpendicular to the y-axis, so they're going the other direction. Let's drop our y-axis flat, and here are the semicircles. Notice it's not quite a cone, and it's not quite a right cone either, because it's over off to the side. And here we have the semicircles sweeping through. Notice how the diameter is this distance across, which is your x value. Here's our solid. And here are the 5 semicircles inside it. So I hope you guys get a better idea of what this looks like in terms of a solid.